Okay, let's go ahead and give a start to 3.3, properties of functions. So we're going to talk about even and odd functions, and then we're going to go ahead and test them. So here we have an even function. If, when you plug in negative x, it's equal to the original equation. So the key thing here to kind of box is this. And that's going to be an even function. They are symmetric with respect to the y-axis. So remember when we did symmetry with the y-axis, you would plug in negative x to check it. So that's why we're plugging in negative x in function notation, and you would see, is it the same as the original one? So remember, we used to plug in the negative x in our other unit. We also have what we call an odd function. An odd function is going to be symmetric with respect to the origin, okay? So that when you plug in negative x, it's also going to be equal to the negative of the whole y thing. So that's when we plugged in the negative x and the negative y before. So the key thing to remember, I'm going to go ahead and box here. So when you're going to go ahead and test it, what I tell students to do is to test for three things. So the first thing you're going to go ahead and test for, or the first thing you're going to go ahead and find is what is f of x, which they give you. So step one is no work. Step two, you're going to go ahead and plug in negative x. And then step three, you're going to find negative f of x. If the first two are the same, we have an even function. If the second two are going to be the same, you're going to have an odd function, okay? So let's go ahead and take a look. So the first thing, again, that you're going to go ahead and do is find what f of x is. They tell you that, so you don't need to do anything. The second thing you're going to go ahead and do is find what is f of negative x. So you're going to plug negative x into the function. So we've got negative 3. Instead of x, I'm plugging in negative x, squaring it, minus 7. So the key thing that I would be looking for is right here, this negative x, the parentheses exactly the same way, just like we've talked about before. Negative x squared is going to be a positive x squared. A negative times a negative is a positive, minus 7. Now remember, if this equation is the same as this equation, then it's going to be even. So we're done. They are the same. You don't have to check negative f of x. If 1 and 2 are the same, you can stop. It's even because f of x is equal to f of negative x. Okay, let's try that again. Now we've got a g function. If we look at the g function, again, step 1 is to know what the function is. We've got that. Step 2 is we're going to go ahead and plug in negative x. So 2 times negative x cubed minus negative x. And you're going to simplify. Again, I'm looking for those parentheses exactly around it when you plug it in. Negative x cubed is going to be a negative because you have 3 negatives, which makes it a negative. Then we have a minus negative, which is a plus. Notice that 1 and 2 are not the same, so it's not going to be even, okay? Now let's go ahead and do negative g of x. That's the third step. Negative g of x means you take the negative of the entire function. So it's pretty much flipping the signs of the original g function. So negative gx cubed plus x. If these two equations are the same, 2 and 3, so not 1 and 3, 2 and 3 are the same, then it's going to be odd. So it's the same because g of negative x equals negative g of x. So think of that as step 2 equals step 3, where the other one, step 1, was equal to step 2, okay? Okay, we've got an h function. Typically, I would have students try this on their own now that I've done 2. So I would pause me and then try it. All right, welcome back. So you should be plugging in negative x into h. When you do that, we should go ahead and get a negative, because 3 negatives is a negative. This is not the same, so I'm going to go on to the next step. So we have step 1, step 2, now I'm on to step 3, negative h of x, so negative of this whole thing. So negative 3x cubed plus 5. A lot of you can just take the negative without even showing work. You just flip those signs around. Negative 3x cubed. Oops, I made a mistake. Minus 5 because I distribute that negative sign. And then I check, are 2 and 3 the same? Nope. So for that reason, it's going to be neither, because f of x does not equal f of negative x. That would have been even. And also, f of negative x does not equal negative f of x. So it's not even or odd. Okay. Other important things about functions is knowing when things increase or decrease. So an increasing function is going to be when something is going up. Kind of like slope, but it doesn't have to be a straight line, so it could have curves to it. So this would be increasing and increasing. So it's moving up from left to right. We also can have decreasing functions. So if we take a look at decreasing function, a decreasing function is going to be moving down from left to right. So if you look at just a straight linear equation, it looks like that. But we also can have them with curves. So something like those. And then we also have a constant function. A constant function is going to be when the graph is horizontal. Okay? So only one type for that. Okay. They're going to ask you to tell when it's increasing, decreasing, or constant. And the thing is, they're going to ask for them in interval notation. So when they're in interval notation, it's always going to be the x values. Remember, the intervals are always going to go from left to right. And because you're always going from left to right, you have to think smallest to largest. Or I always think of it as from x to x. That's how you're labeling it, from x to x. You have to decide if it's a parenthesis or a bracket depending on the actual problem. So let's go ahead and take a look. So here we have a graph here. It wants to know when is it increasing. So increasing is going to be going up. So there's this curve here, and the only part that is increasing is that little part right there. When is it increasing from? It's increasing from x to x. So what's the x value here and what's the x value here? The x value at the first spot is located at 0, and the x value at this other one, assuming it's counting by ones, which I think it is, yes, because the x's, the two bends are at the point 0, 0, and 5, 25. So this is a 5, because that's where it bends. So it's increasing from 0 to 5, or between 0 and 5. Now let's continue to take a look, and this should have arrows. It's just a picture of your calculator, and your calculator doesn't show errors. When is the function decreasing? So decreasing is going down from left to right. So this is going down from left to right. So this decreasing portion here, so again, this one's increasing. So you can write notes to yourself, decreasing. From left to right, it has an arrow going to the left. So that means it's going to be from negative infinity until this spot right here, which we're going to talk about. It's called a minimum or a turning point. So negative infinity to 0. Or if you write that as an inequality, x is less than 0. Lastly, it's going to be constant, which means just that horizontal line from what to what. So this one started at an x value of 5, and it goes until infinity. Okay, other important words with functions, because these are going to all be mixed up together, is knowing what a maximum and a minimum is, and what a local max and local min versus absolute. So first, let's just kind of talk about generally what is a maximum and minimum. So generally, what is a maximum and a minimum is, you guys have talked about these with quadratics. When you saw a quadratic like this, you knew that that was a maximum point, okay? So you've seen this with quadratics in Algebra 2. And you've seen when it goes down like this, that this is a minimum point. So we've got our maximum, we've got our minimum. So if we have a local key word here being local, if you're going to see that word local in here, then that means that it's going to have, could have more than one maximum or minimum. Could have more than one. When you see the word absolute, it's of the entire graph. So it could have at most one. So think of absolute monarchy. There's just one king or just one queen. So just one for absolute. Local can have many. Now you might be wondering with the U shape, how does that happen? Well, the shapes aren't going to be just these U shapes anymore, quadratics. We're going to have x cubed, x to the fourth, x to the fifth, which can make more curves in your graph. So we could have something like this. If you have a graph like this, notice that we have two maximums, okay? Or same thing for the minimum, and you could have more than two. It could be like, woo. So these minimums occur when it goes from increasing to decreasing. Or decreasing to increasing, depending if you're looking left to right. And there would be three in this one. So I think of them as the valleys, the bottom of the valleys, right? Okay, so those are like the valleys. So we've got maximum, we've got minimum. For the absolute, you're looking at the entire thing and you're asking yourself, which point is the highest? Because if there is more than one, you want to know which point is the highest, if it's a maximum, that is. And if it's a minimum, you're asking yourself, which point is the lowest? And not so much the point, but which y value, I should say. That's because whenever we actually say max and mins, we're talking about the y values. They want to know how high, how low. So while we look at it as a point visually, you're actually going to be telling them what the y value is, okay? That can include an endpoint, for instance, where when you're looking at locals, it actually has to not be an endpoint. It has to be a full hill or a full valley, okay? So you have to have the up and the down, or the down and the up, okay? Where for the absolute, it's of the whole thing, so it doesn't have to, notice how this doesn't come back down right away. It's okay, it's whatever the highest point is. So you could consider this an absolute max, but not a local max. Okay, so if we take a look here, we're going to skip the extreme value theorem for a minute, and let's do some examples. So here we have a graph. It says the function f has a local maximum at. So let's take a look. They're looking at local maximum, okay? So local maximum. So local can be more than one, and we're talking about something that is going to be a hill. So we're zoning in on this point right here. This is going to be a possible local max, and it is a local max. We're saying it is at, the location is at -1, but the actual value is going to be a y value. The y value is 7, because again, f of x means y. So a lot of times you'll see that language where the local maximum is at x equals -1, so the value is 7. And the value is talking about the y value. It has a local minimum at, so now let's look at the local minimums. Remember, local minimums can have more than one. So here we're looking here and here. Those are going to be the valleys, okay? So we have two of them. We have them at x equals -5 and at x equals 2. Respectively, the local minimum value f of x, so the y values of those respectively are going to be at 1 and at -6. When I say respectively, that means in order. So again, these are going to be your local minimums, because you can have more than one. This is your local max. Okay, now let's talk about absolute. when we're going to go ahead and talk about our absolute maximum, our absolute maximum is going to, actually, let's talk about the absolute minimum first. So the absolute minimum is located at -5, 1 and 2, -6. Those are the two local mins. If we look at which one is the lowest point on the graph, the absolute lowest point on the graph is going to be located at -6. This one right here is going to be also specifically the absolute minimum. You can only have one of those. So the function f has an absolute minimum at x equals 2. So the absolute minimum value, so the actual value, f of x just means y, is located at -6. So we're only going to have one there. All right, let's go ahead and look back at the absolute maximum. For the absolute maximum is going to be at that same high value here, since we don't have endpoints, and the endpoints are truly just infinities. So we can still call that value is at x equals -1, so y is equal to 7, since we don't have endpoints and we have arrows. So that is also going to be your absolute max. Okay. So let's go ahead and take a look. I'm going to have you try this one. This one is a little bit different. It does have endpoints and not arrows here, so we're not going to put arrows here. We're going to keep those listed as, oh no, you're trying example 5. I'm going to do this one. We're going to keep those endpoints there. It says the function f has a local maximum at. So when we talk about local, it has to be a complete hill. So the local maximum is just going to be at this point here. So we're going to go ahead and say for the local maximum, which I did in blue, is at x equals -6. So the local maximum value is f of x equals 4. So this is going to be your local max. You're not going to include the other one because it's not a full hill. It doesn't come down. We don't know what it does. It just ends there. It also has a local minimum. Same thing here. We don't know exactly what it's doing. So there's just one. So it's just going to be a, what color did I use? Red. This is going to be our local min because it's got to be a full U, okay? So it's at x equals -3. So the local minimum value is f of x equals -8. Okay. Now when we're doing absolute, we're going to take the endpoints into account now so that if they're higher or lower than them, they could be the answer. So let's take a look though. So here it has an absolute maximum at, what is the highest point, the highest y value that it goes to? It happens to be the same as this one. Notice 2 is not higher than 4. Otherwise, if 2 was, you could say that. So this is also going to be the absolute max. So at x equals -6, the y value is 4. When we look at the minimum, again, the absolute lowest point, since these are endpoints, you can take them into account. But the absolute lowest one happens to actually still be the same thing. This is the absolute minimum. So it's at x equals -3 with a y value. Oops, they kind of cut out, the f of x got separated. But f of x is equal to the y value, which is -8. I don't like that it got separated. There we go. Okay, just to practice increasing and decreasing. So remember, if we're going to go ahead and do increasing and decreasing here, this is going to be going up from left to right. So this is increasing. So increasing from left to right, remember, is x to x. So what is the x value here? The x value is at -8. And it goes until the x value, which is located at -6. You have to think, a lot of times the actual min or max points, they use a parenthesis. Math Excel will mark you right either way. But if it's an endpoint, I want to include that point, so I do use a bracket. Now this side over here from x to x is -3 to 2. So we've got -3, and then 2 is that endpoint there. Where is it decreasing on? So let's take a look here. It's going to be decreasing, going down here in the middle, just one section. So it's going to be decreasing from a x value of -6 until -3. And then that's it. Again, that's not a coordinate point. That is from x to x. Okay, now you're gonna go ahead and try example 5 all together. So pause me and just give it a go. All right, welcome back. Let's go ahead and give this a try together. So the function f has a local maximum at. So remember, local can mean more than 1. So we've got one here, and we've got one here, okay? So we say at x equals -3 and at x equals 2. Respectively, that means their values are their y values, which would be 2 and 1. The local minimums, which remember, they had to be full U's, just like these had to be full hills. We've got 2 of them here, here, and here. It has a local minimum at x equals -1 and 4, but the actual values of it are -3 and -1. So those were your local mins. These are your local maxes. Okay, when we take a look at the absolute, we don't have endpoints, we have arrows, so we're going to focus in on the points we already have circled, okay? So it can't be one of the endpoints because we don't have endpoints, they're arrows. So where does it have an absolute? The absolute is going to be the highest of the whole entire thing, which is right, not including the arrows, though, so it's going to be right here. This is going to be our absolute max. Our absolute max is at x equals -3 when the y value is 2. And then our absolute min, for the same reasons, is going to be here. It's when x equals -1, our y value is -3. Okay? Where is it increasing and decreasing? So let's take a look. It's going to be decreasing at 2 sections. So from left to right at 2 sections. So I'm going to do decreasing first because that's what I just started. So it's the second line. From x to x. So from -3 until -1. Union from 2 to 4. From that x to that x. Done. When we're going to go ahead and talk about our increasing here. Let's go purple. We're increasing in 3 sections from left to right. So from left to right, we start at -infinity. This left part here, it goes up until the x value of -3. Union, the next one is -1 to 2 for the x values. Union from 4, and it goes to the right, from 4 to infinity. So again, when you're doing these ones, you want to make sure you're doing x to x always, okay? Okay,